We are honored to have Mr. Akilur Rahman, Chief Technology Officer, Hitachi India Private Limited. Mr. Akilur Rahman is the leading technology, digitalization, and innovation towards the market and customers in India and supporting market innovation in South Asia. He has more than 3 decades of experience in research, R&D, technology management, engineering, consultancy, business, and product development in power, automation, and digital technologies. With a master's degree in electrical engineering from IIT Kharagpur, he has held various international and global roles in India, Germany, Switzerland, including head of global collaborative production management, engineering and cybersecurity. In process industrial automation, he was responsible for building up ABB's global automation software product and system R&D in India. Today, Mr. Akilur will talk about technology and business model innovation for energy transition.
We are here to discuss basically a review of the sustainable energy transition. And as it has been spoken earlier also that especially as a country, our target, carbon neutral target is 2070. And then we also have a very clear target in terms of renewable, and which is part of the energy transition, that by 2030 we are going to have 500 gigawatts of renewable energy, which is going to be half of the total electrical energy by then. And of course, if we backcast 2030, I think today we have a lot of actions already in place to achieve this target. For example, Karnataka as a state where I'm coming from, in the sense where I'm speaking from, Bangalore, that this state already achieved the 50% target, renewable target in the year 2019 itself. Rest of other states, I think they will also be moving towards that. But we also need to see how, in terms of technology and also business model, how it is supporting this kind of transition, whether it is 2030 target and also the long-term target of 2070, which is the carbon neutral target. I'll provide a very overview of different technologies, where are they, and then what is required to achieve the target very quickly. And you see this different building blocks, elements of the energy transition. So we are seeing that from the conventional, we are also going into the solar, very heavily on solar in India. Onshore wind, which is on the land, but also in future probably offshore wind, which is going to come offshore in the sea. And then that is already, as Hitachi Energy, we have done that in Europe, in places, in the deep in the sea, the windmills, they are connected and evacuating the power to the shore. Hydropower, conventional, of course, they are going to be there. But in terms of technologies for transmission and distribution, I think we are seeing increasingly the power electronic based technology, because we need more control in the grid, because as we add more and more solar energy, wind energy, which are intermittent, and also solar, there is no inertia, so we are losing inertia in the system. So we need to have control of the grid with these technologies. And on the consumption side, we do see that in addition to the electric vehicles and data center sort of consuming huge amount of power, and also we are looking at the hydrogen, the green hydrogen, production, consumption using the renewable energy, and commercial, lot of commercial and industrial, I think, energy. They are also going to convert to electrical energy, either as a carrier or the energy, direct energy itself. So, and we have to look at different sectors: utilities, renewable, transportation, data center, industries, building, in the entire value chain of an energy transition. And so that's why we have to look at the entire ecosystem, the entire grid, from source to the consumption point, and also presumption point. Presumption, because we are also seeing that the consumers, they are also going to be prosumer in terms of both consuming as well as producing, in terms of solar rooftop or storing energy, and feeding it to the grid, back to the grid whenever it is surplus, and whenever there is requirement by the grid. So I'm just trying to show how 2050 the system would look like. It's of course a very busy slide, but I'm not getting into the technology so much inside. But if you look at conventionally, it was very clear: generation, transmission, distribution, and all the different sources and consumption, they are very clearly defined. But in future, it's going to be very, very different, very diverse in terms of generation, not only the conventional, but also the renewable, for example, solar, wind, storage, pumped hydro storage, battery energy storage, and of course green hydrogen fuel cell based storage, they are going to be there. And a lot of microgrids, basically in the remote areas or even industrial residential complexes, where renewable generation plus storage will be there and working as a microgrid standalone, as well as connecting with the grid whenever it is required. So on the consumption side, it is consumption again, because it's not only just consuming but also producing. So we'll have also a lot of electric vehicle charging system, fast charging, flash charging, ultra fast, and the grid has to sustain that. Energy storage, battery energy storage, green hydrogen fuel cell based storage. So as I said, with all these diverse sources of energy, consumption of energy, and at the same time losing the inertia in the system in terms of having more and more solar and less of rotating mass, so we need to have better control. So that's why the industry, the utility is also moving towards DC technology, high voltage DC, for example, which gives us the control of the power flow, bi-directional power flow, and also whenever there is a fault, it can also sort of control the power in a way that whether it is voltage, frequency, it can contain it within the grid, not really leading to any tripping or cascaded tripping or blackout. So that's why power electronics technology, whether it's HVDC, the flexible AC transmission, and the reactive power compensation, STATCOM, they are going to be very important, which we are seeing now increasingly it is happening. For example, in India, we see that from Leh Ladakh area, where we'll have tens of gigawatts of renewable energy. So how to transmit that power to, let's say, Delhi, NCR region, Haryana, so that it can be connected to the grid and feed to the grid. Then we are exploring HVDC technology there. From deserts of Rajasthan, evacuating a huge amount of power, gigawatts of power to the grid. From Kutch of Gujarat, and of course, as I said, in future also the offshore, deep in the sea, uh, the wind energy, how it can be evacuated. So I think these technologies will play a role in terms of whether we should do it with AC, conventional AC, or HVDC, because HVDC provides both control and voltage, reducing the voltage drop, at the same time environmental footprint. I think these are the technologies which are going to be playing a role. Not getting into the details, I think the technologies are there, like in Hitachi Energy as well as many of the other OEMs. We have the technology how to strengthen the grid, the power grid, whether it is the utility grid or even the industrial grid. The system strength, there are different ways to provide strength to the system: synchronous generation, grid farming, battery energy storage, and reactive power compensation. And similarly, in the voltage control, we use different technologies, including the power electronic base, as well as the synchronous condenser, energy storage, frequency control, inertia I talked about. So creating also virtual inertia in the system to contain this problem, which may come out because of non rotating mass energy generation like solar. Yeah. And of course, the HVDC technology, which can be there for connecting two different systems back to back. It can be two regions. There are installations in India, and also for the with the neighboring countries, probably it can be also there to have a little bit of decoupling of the two systems, so that any contingencies should not be transferred to the other one. So HVDC can be overhead lines, it can be undersea. So in Europe, for example, we have installed many of the system with undersea cabling and with an undersea HVDC link. So And as I said, it can be for connecting different regions within the country, clusters in the sense the solar power in Rajasthan deserts or Kutch or in Leh, Ladakh, Himalayas. So all these technologies can be used. They're there. And what's important also having this core technology, also digitalization, because that is how we can monitor the performance of the assets, performance of these different sources of energy, consumption, presumption. Uh, so conventionally, the power system is digitalized since 1990s. I mean, we have the digitalization, automation, protection control, SCADA, EMS, energy management system, and all those there, the network control. But what we are doing also now, putting additional sensors in the system, data is available in the cloud so that we can do the performance management, asset performance management, also have the KPIs in the system, whether it is productivity, reliability, the quality of power, and asset health, all the important asset, whether it's a generation asset, all the power evacuation asset, transformers, and energy efficiency. It's not just generating energy and consuming, but also ensuring energy efficiency is improved, safety of people, environment, security. So these are the KPIs which we can measure and improve using the digital technologies on top of the conventional core automation technology. So it can be AR, VR, digital twin. This is what we are doing already. For example, we came up with the world's first digital twin for large electrical installations, FACTS, HVDC, and AI/ML to have better predictability of the assets, asset health, as well as the renewable energy in terms of generation consumption, and using different technologies, 5G coming in future, blockchain for smart contract among the prosumers, and of course cybersecurity. So to have all these, we need a lot of investments. The utilities, the industries, they need investments, large investments. So, but there is always, question the ROI. I think this is where we need a new business model, innovation in the business model, in terms of converting the capex to opex, where a lot of energy, green energy funding can be used. Energy as a service. So the infrastructure, the assets of the energy, they can be owned by a company, and then the operating company can just work on the operating costs, so that there is sort of decoupling between the ROI, large long-term ROI, with the day-to-day operations. Storage as a service, storing the energy, whether it's battery energy storage or hydrogen fuel cell based storage, pumped hydro storage. Battery as a service for electric vehicles, so where you don't have to bother about buying battery. So battery is going to be owned by the company, and then you will be charged based on the number of kilometers you use it, and then the availability of the battery. Charging as a service for the charging infrastructure, so where again they can provide this to the vehicle owners as a service per unit of charging they provide to the vehicles. I think in future it's going to be a combination of technology innovation as well as business model innovation. And while we have in India, we have resources, we have potential for renewable energy transition, huge potential. There are investments also, there are companies in utilities that are willing to, but I think they have to bring in the technology and also the digitalization together with a innovative business model so that it can be adapted faster. So I'm sure that it can be done. So far we have done with the conventional way, but in future it can be done with a very smart way of business innovation, as well as technology innovation together. So this needs collaboration among all the stakeholders, and I'm sure that we can come together, whether it is the utilities, industries, OEMs, technology providers like us, and also the owners, operators of the energy resources as well as consumption points.
Thank you, Mr. Akilur, for sharing your views on technology and business model innovation for energy transition.